for this one, it is a 67 add binary. So we are giving two binary string, and we need to sum of the two strings, but the final result is going to be a binary string. So we're going to return their sum as a binary string. So for example, a equals to 1, 1, b equals to 1. So finally, it's going to be binary string 1, 0, 0. So this is because this is 1, 1, this is 0, 1. So 1 plus 1 going to become 0. Here we have a carry. 1 plus 1 going to become 0. Here going to have a carry 1. So finally, it's going to be string 1, 0, 0. Yeah, we just need to sum up of two strings, but it's going to be the binary string. So normally we're going to use a carry. So now let's solve it directly. We can define a carry. So from the beginning, it's going to be 0. Now we're going to define two pointers I and j. So I is going to be equal to a dot length minus 1. So because we're going to place it from the right to the left side, so it is from the least significant digits to the most significant digits. So j is going to equal to b dot length minus 1. So the condition is that we're going to use a while tag. While I is more than equal to 0, or j is more than equal to 0, or there's still a carry inside. So carry is going to be more than 0. Otherwise, if carry equal to 0, we will not consider the carry. Yeah, so in this way, we will calculate all of them together. We don't need to check if we have a carry or not, because we're going to calculate them together. Yeah, but what's going to be the final result? We're going to prepare a string builder. So in Java, we're going to have a string builder, and this is more efficient by using the string. Yeah, because we can use the string builder to append any kind of numbers or string. Finally, it's going to become a string. So it's going to be a new string builder. So inside, we need to check if I is more than or equal to 0. So this means, yeah, we can put it to our final result. So here we're going to define an integer as the sum. It's going to be starting from a carry. Yeah. So from the beginning, sum is 0, and then we're going to use this sum plus the carry. So from the beginning, we're going to define this sum equal to the carry, because finally this carry can become 0 or 1. We don't know. So this is why we're going to just define an integer sum equal to the carry. So if I is more than equal to 0, so sum gonna plus equal to a dot. Here we're gonna use character at. So it's gonna be character at I minus minus. So this means first of all, we're gonna find the character at the position I. So for example, here we're gonna find this character, it is 1, and then we're gonna update this pointer to the next character. So we're going to use I minus minus. This means we're going to calculate I first, and then I going to minus by 1. So because of this, a dot character add, we finally get a character which is 1, and we're going to use a minus to get the integer calculation. So character 1 minus character 0, so finally it's going to become 1. If character 0 minus character 0, it's going to become 0. So this is why we're going to use the sum integer plus another integer. Similarly, we're going to check if j is more than and equal to 0, we're going to update the sum, going to plus equal to b dot. Here we're going to use the character at j minus minus and minus 0. Now we get the calculation of this sum. So for example, this one plus this one, so it's going to become 2. So the result gonna append a 0. So how can we get a 0? So we're gonna use the sum modular 2. So if it is 2, because it is the sum modular 2. So if this is 2, so we're gonna get a 0. And we need to update the carry. So carry gonna equal to sum divided by 2. So this means if sum equal to 2, carry gonna become 1. If sum is 1, so carry gonna become 0. If sum is 0, so carry gonna become 0 as well. So finally, we just need to return result dot reverse. This is because if we calculate all of them, this is append. We just append, for example, 0, 0, 1. Finally, we need to get the final result. We need to reverse it, because the final result is going to be from the most significant digit to the least significant digit. So we need to reverse it, and then we're going to turn it to a string. Now let me just run it to check if it works. What is wrong with it? So index 1 out of bounds for length 1. Yeah, because here I use it should be a b dot length. I used the a dot length. That is why index 1 goes out of the bounds, because this is the index 0, and from it should be from index 0, but from the beginning we are checking index 1, but for b it doesn't have an index 1. This is why, because I made a mistake from here. It should be b dot length for this pointer or for the index tree. Now let me just run it. Now as you can see it works. Now let me just submit it. As you can see, it passed all testing cases and it's pretty fast, and the time complexity is the length of string A plus the length of string B. Basically it is a linear algorithm, so the time complexity is going to be O m plus n. I think that's all about it. Thanks for watching. See you next time.